Welcome back to week 4 of my 6-mark challenge for AQA GCSE Science. In the run-up to the exams, I'm posting a new video each day with a 6-mark question so that you can practice how to answer them. You can find a link in the description below to each week's questions and access all of the videos via the playlist. Today's question comes from the bioenergetics topic of GCSE Biology Paper 1. Before you dive in, don't forget, this isn't an essay question, much as it looks like one. You don't get any marks for writing in full sentences or paragraphs, and we don't want any flowery language. Ideally, you want to answer as bullet points or giving your method as a numbered list. Try to include one instruction per line to make it really easy for your examiner to follow. If you can name the equipment, then it's a good idea to do so, particularly with these type of method questions. And finally, consider, will the method that you've written lead to valid data? Could you give these instructions to somebody else, and if they followed them, would they be able to get the data they would need to answer the question? That's a prerequisite of a level 3 answer, so if you wouldn't get valid data, you can get a maximum of 4 marks. If you haven't done so already, pause the video now and give yourself 6 minutes to answer this 6-mark question. Whenever you're asked to write a method for one of the required practicals, or in fact any practical, it's a really good idea to start by identifying the variables and explicitly writing these down on your exam paper. This is going to get your head in the right place, but also it means that when you go back and check your answer, you can make sure that you have actually talked about changing the independent variable, you have talked about measuring the dependent variable, and you have talked about controlling at least one control variable. It's very, very common that we see questions where candidates have written quite a nice answer for a method for the first time through, but they've forgotten to include measuring and writing down their results, or they've forgotten to say, then go back and change something. So this is a really good way of forcing yourself to check it. So in this investigation, the thing that we're changing, the independent variable, is the light intensity. So you need to think about how you're going to change that. Then the rate of photosynthesis is our dependent variable, so you need to think about how you can actually measure that, because you can't look into the cells and see how much photosynthesis they're doing. And then the variables that you're going to want to control are the other limiting factors for photosynthesis apart from light. So in other words, how much carbon dioxide is available and what the temperature is. Now in terms of the method for this practical, we're going to start off with a beaker of water and we're going to put an aquatic plant inside it. Then you're probably going to have added some sodium bicarbonate in order to saturate the water with carbon dioxide, so that there's so much carbon dioxide in there that that cannot possibly be a limiting factor. You may have placed your beaker of water inside a water bath in order to control the temperature. Alternatively, you could have used a heat screen, which will prevent that heat from coming through, or you might have chosen to use an LED bulb instead of a regular lamp, because that's much cooler and so it's unlikely to warm up the plant as it's turned on. You're then going to use a ruler to place the lamp, say 20 centimetres away from the plant. The specific distance doesn't matter, but it needs to be a sensible one. You switch on the lamp and leave it to acclimatise for a little while, because the plant isn't suddenly going to start photosynthesising faster, it's going to take it a little while to start catching up. Then you're going to time for a certain amount of time, and personally I always find it easier to just state a time like a minute, rather than say, do this multiple times and always keep the time the same. And you're either going to count the number of bubbles being released by the plant as it produces oxygen for photosynthesis, or you might collect the gas and measure the total volume that's being produced. Next, you're going to repeat this and you're going to move the lamp different distances away from the plant. It's possible that instead of moving the lamp, you might have talked about maybe if you had a lamp where you could adjust the brightness, doing something about that, but using a ruler and moving the lamp is kind of the more normal way of doing things. And of course, we're going to have to repeat these steps where we count the number of bubbles over a certain amount of time. We're also probably going to talk about repeating this for each distance so that you have multiple pieces of data for 20 centimetres and 30 centimetres and 40 centimetres, and then for each distance calculating a mean. As I've mentioned in previous videos, you don't actually need to have said everything that I have on this slide in order to get 6 marks, so don't be disheartened if you've missed out a few things. The crucial thing is that your method has to give us valid data that would allow us to answer the question. So there are certain things that are non-negotiable. The first thing is that you have to have a plant that is underwater, because if it's not underwater, if you've just got a regular land plant, we're not going to be able to measure the amount of gas that's being produced. The second thing is that you have to have a control variable. So it doesn't matter whether you've controlled temperature or carbon dioxide, but you need to have included one of them. So then if you've used a heat screen, it doesn't matter if you haven't mentioned the sodium bicarbonate. You need to have some way of knowing what your initial light intensity is. So either you've put your plant a set distance away from the lamp, or you've got some sort of adjustable lamp and you've made a record of what the light intensity is based on that. Then you need to have measured for a certain amount of time, and you need to have either counted the bubbles or measured the volume of gas. And then you need to have actually changed your independent variable. It's also important that you talk about repeating this, and when you repeat, you only get credit if you talk about repeating and calculating a mean. So I would say that they are the 6 things that you need to have included in order to get your 6 marks. Tomorrow's question is another one of the GCSE Chemistry Required Practicals. Don't forget, there's a link in the description below to all of this week's questions, and also in the playlist you'll find all of the previous videos if you've missed any days so far. Thank you very much for watching, and I hope to see you again tomorrow for day 20 of the 6 Mark Challenge. If you found this video useful, then don't forget to like and subscribe for more GCSE Science revision videos coming soon.